Welcome to some consecutive probability. Alright, so let's check this out. The question I'm going to pose to you, I'll type it out right here. What are the chances of rolling 3 sixes in a row? Or 3 of any number in a row. This would be the same thing because all of them start with the same probability. So this relies on consecutive probability. The only way you could get 2 in a row is if you first get 1 in a row. So just take this example. Let me just roll a die. Okay, I got a 5. Okay, so let's just pretend now I change this. I say, what are the chances of getting 3 5s in a row? It's going to be very unlikely. The first thing that we're going to look at when we set this up is what are the chances of getting 1 5 in a row? When we rolled this die, there were 6 different possibilities. It's a 6-sided die. So you had only one of those sides. That was a 5. So you had a 1 in 6 chance of landing on a 5. And let me also represent that as a percentage. 1 in 6, and I'll just keep the calculator out here because I'm going to need it for the next problem. So I'm going to just keep it along the side right here. And a 1 in 6 chance as a percentage is 16.67%. So when you're working with consecutive probability, it's really important that you start here with step number 1, which is in order to get 2 in a row, you have to first hit on that 1 in 6 or 16.67% chance. You can't even think about 2 unless you hit on that 1 in 6 chance. That's why the next step relies on you getting this first step. So now, to get 2 5s. Some of you might have been looking at that and said, oh, you made a typo. Don't care. 2 5s in a row. Obviously, to get another 5, it's a 1 in 6 chance. But that's not the question. It's what is the chance that you're going to get this 1 out of 6 chance and then get that 1 in 6 chance again. So watch this. It's not going to happen. See, I can tell you it's not going to happen because it's a very slim chance. Let me actually map this out so you can think along with me here. Here is step number 1. You had a 1 in 6 chance. So I'm going to draw just some lines. 1, 2, 3, 4, 5. So you only had this 1 in 6 chance that you are actually going to hit a 5 for your first row. Now, on your second row, you're only working with that slim percentage now. Your box is only this big because it's assuming that you've gotten that 1 out of 6 if you're trying to get that second 5 in a row. So now you actually are finding 1/6, 2, 3, 4. See, this is how hard it is. You're actually now needing to get a 1/6 of 1/6. And that's what the model shows. You need to first get this part in order to even talk about getting this part. So that becomes, you have a 1/6 of the 1/6, which you know how to do the multiplication there. That is a 1 in 36 times. So you're going to have to spin that die 36 times to actually get 2 5s in a row. There's 1. I'll make it go fast. Oh, there are 2 3s in a row. 2 6s in a row. I haven't hit a single 5 yet. This thing is rigged. This is rigged. Never trust computer dice. Never trust computer dice. 5. Tell me if you see a 5. Come on, puppy. 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 5. Oh, another 5. Oh, 5. Oh. See, it's a slim shot. And if we look at it as a percentage, essentially what you're doing is you're taking this 16.67% chance, which is this part right here, and now you're dividing that by 6, which is now a 2.77 or a 2.78% chance if we do the rounding. And I'll just show you again real quickly. So you took that 16.67% and now you have to find 1/6 of that because that's what you're working with. You're assuming you get that 16.67% chance. And now you have a 1 in 6 of that. By the way, you'll see if I do 1/36, it's the same thing. We'll just get that as a percentage. Times 100 is 2.78. So it winds up being the same thing. Now let's talk about 3 times in a row. And you're going to start to realize how rare and how difficult that would be to get 3 5s in a row. Because in order to get 3 5s in a row, you have to first hit on that 1/6 chance. And then you have to hit on that second 1/6 of 1/6. So now you're at 2.78% chance. And now you have to find boy, what's happening? Delete of 1/6. So I don't even know how to do this math. You have to now take this wee little part right here and divide that into 1/6 parts to get a 5 for the first row, 5 for the second row, and 5 for the third row. So the only way I could do it is 6 times 6 times 6. So to get that, that is now a 1 in 216 chance. Or you can take that 2.78 and divide that by 6 again, that 2.78%, which is 0.46% chance. How rare is that? Amazingly difficult, which, by the way, is 1 divided by 216, but that's a decimal, so if we multiply that by 100 to be a percent, it's 0.46% chance. That's less than 1 in 100 times that you were going to get 5 turning up 3 times in a row. That is crazy. You're going to have to watch this 216 times to land on something that's 3 times in a row. See, doesn't happen. Doesn't happen. Nope, it's not going to happen. There's 1, 3. H3. Am I even going to get 2 times in a row? Computer dice are so rigged. Never trust them. I got a 5. Oh, there are 2 3s in a row. Could this be the 1 in 216 times that I get 3 3s in a row? Let's watch and see. No, of course not. Because we would have to stay here all night. That's how consecutive probability works. It keeps getting harder and harder and harder. Now think about that and apply that to life, man. Let's go.